I'm gonna demonstrate standard test method for air conduit of freshly mixed concrete by pressure method as per ASTM C231. First of all, I'm gonna explain the scope of this test method. This test method covers determination of air conduit of freshly mixed concrete from observation of change in volume of concrete with change pressure. Now I'm gonna give a little bit information regarding apparatus. As per section 4.1 air meters, there are available satisfactory apparatus of two basic operational designs employing the principle of Boyle's law. For purposes of references herein, these are design meter. We have got one type A and the second one air meter is type B. But we are performing tests by type B method. In section 4, the apparatus shall consist of all these equipments we got here. Because we are using type B meter, we have got measuring bowl as a per section, which is this one. As per section 4.2, the measuring bowl shall be of 5.7 liter capacity, which is in section 3 we have got assembly cover or cover assembly. As per section 4.3, the cover assembly shall be made of steel or hard metal such a way that it shall cover the measuring bowl so firmly and consist of flames to cover the measuring bowl tightly. And calibration vessel as per section 4, which is this one, this is called calibration vessels. And we have trowel, a standard brick mason's trowel as per section 4.8. We have tamping rod as per section 4.9, a round steel rod of 16 mm diameter, which is in 24-inch long, and also a rubber mallet. I'll put it here. And we have a rubber mallet as per section 4.10. The rubber mallet shall be of weight 0.23 kgs. And we have strake of bar. Strake of bar is as per section 4.11. The strake of bar shall be 12-inch long, which is here we go. And also measure for water and scope is needed as well. So we can use different equipments, but this is measure for water and scope cylinder. As you can see, we have got two kinds of coarse aggregate. As you can see here, and we have got fine material. We have already passed in from 3x8 CU as well. According to C231 section 6, based on our batch weight, we have prepared air training agent 7.84 ml. Therefore, we will put into our trial and we will mix in it. As you can see, we have prepared our mix. Yeah, it's done. Okay, now we are taking air content taste. We are performing or demonstrating it right away. As you can see, we are conducting or demonstrating air content according to ASTM C231 as per section 8.11. First of all, what we need to do, we need to dump inside measuring bowl. Yeah, here we go. Now what I'm gonna do is we will put sample. Okay, now each layer should be consolidated 25 and 3 layers 25 blues each. what I need to do is I need to from 10 till 15 glues with a rubber mallet to take off the remaining air which was caused by tamping rod. Yes. Okay, now we are putting second layer. Each layer equal sample. Yep, here we go. Okay, but in the second layer we need to see this, and our sample our tamping rod shouldn't influence more than 1 inch. Here we go, according to this. Okay, now in second layer we are trying not to influence more than 1 inch, which is we are measuring here, and now we are carry on for second layer 25. Okay, for second layer, as I said, our tamping rod shouldn't influence more than 1 inch, as I have measured here 1 inch, and now I will carry on. 1, 2. Here. Again, a rubber mallet for air wads left by tamping rod. Yes. Carry on again for third layer. I have to properly mix all these materials, and then afterwards we are taking sample. Yes. Okay. Again, I have to, from in third layer, we are doing the same, not to influence more than 1 inch. Yep, here we go. Now I'm stringing off the remaining air caused by tamping rod. Take off. Yep. Now I'm using the straight edge, or in the same time we can use trowel as well. What we need to do, we need to level this, and afterwards clean all sides of our measuring barrel. Then afterwards it's gonna give the exact and accurate result. So yeah, it's enough so far. I've cleaned all edges because we are looking forward for exact and accurate result. Yeah, what I'm gonna do now is I will take the cover assembly, and before placing in the measuring bowl we have to put dampen it. Yeah, as you can see it took place, and I will place this on the measuring bowl, and we are getting ready to take the air content. Yeah, we will clump it. As you can see, it's taking place right now. Yes. Now we are opening both petcocks. Yes. And now we are taking our syringe for, we need to put water in it until the water comes off from the other side of petcock. Yeah, as you can see, the water comes off from the other side. Yeah. Yeah. Yeah, the water comes out of from the other petcocks. Now I'm giving a little bit handing jerks because the remaining airs will come off from the petcocks. Yeah, now I will close the air chamber, and now we will carry on till the initial pressure line carry on. After bringing it to the initial pressure line, we need to leave this for a few seconds to cool. I will close both petcocks. As you can see, it took place. Now we are going for reading. We are taking its reading. Yeah. As you can see, we have assumed 5%, and it is exact what we have said according to our design. And we will also show you here, according to our design, we have pretended and assumed it 5% air content, which is there. Now I am opening the air chamber because we have done it. And we release the air. Yeah. I also open both petcocks, and we will open the cover assembly. Yeah. As you can see, we have demonstrated air content. What we're gonna do now, we will gonna carry on our correction factor for air meter. This is done so far. As you can see, based on our trial as we have prepared, we have got our measuring bowl. Our measuring bowl volume is 0.007 cubic meter, and based on these, first of all, we are taking 20 mm aggregate, about 1.76. Yes. 1.76. 1.76. And the second one is 5.42. 5.42. Yeah, it's more. 42. Yes, here we go. And the natural sound is 3.92 from sand. As you can see, it's 3.92. It's prepared, so we will carry on now. As you can see, according to 6.2, as we follow, for example, whenever we're receiving samples from site or whenever we are on site, we need to follow 6.2, but later on I will including its calculation, but at the moment we are carry on according to 6.3, and based on these we are mixing it, and based on its calculation we are taking it, we are doing this in measuring valve, and we will see its results regarding its volume. As you can see, we are following according to 6.3 placement of our aggregates in measuring valve in 3 equal layers. Yes. Yeah. We need to do this from 8 to 12 parts each layer. And we need to put a little water in it. Okay, we continue water until we inundate all aggregate in water. Yes. And we will carry on the next layer. Okay, again. Okay. Again, we need to inundate all aggregate in water. Yes. Again, we will continue. We need to rod this from 8 till 12. We need to put water until inundate all aggregate in water. We need to give with mallet a few blows to take off the remaining air inside in it. As you can see, when all of the aggregate has been placed in the measuring bowl, we are removing excess from the cap and aggregate inundated from period of time approximately equal to the time between introduction of water into the mixer and the time of performing the test for air content before proceeding with the determination as directed in 6.4.2. Okay, as section 6.4.1, our initial inundated time is done. It's alright, and now what I'm going to do is I'm gonna take a look and see, because I've already leveled this and it's level. Yeah, and it's perfect, done. As per 6.4.3, I will put some more water into the measuring bowl till the edges are brim, and afterwards we need to, yeah, it's perfect till the edges are brim. And now Okay, according to our procedure, we need to remove the foam from the top. Yep. Here we go. Okay, as you can see, we have added some more water and it's absolutely done. It's completed. Now I need to remove 5% of water according to our procedure. As you know, our measuring bowl volume is 0.007 cubic meter, and based on this we need to remove 5% of water. So here we go. We need to write down 5% divided by 100 multiplied by our volume 0.007 is gonna be equal to 5 divided by 100 multiplied by 0.007 is equal to 0.00035 cubic liter. Afterwards we need to convert this to liter. So whenever we convert this to liter, we need to write down 0.0035 multiply with 1000. Yeah, we will use our calculator now. 0.0035 multiply with 1000 is equal to 0.35 liter or 350 milliliter. As you can see, it's empty. We need to remove 350 milliliter water from our measuring bowl. Yes, we have gathered. Yes. Quite visible, I think. It's more than 100. We still need to remove some more water from. This is based on our calculation. We need 5%, which was converted to milliliter. It's 350, and the remaining water in the syringe is going back to our measuring bowl. See? Okay, now I'm dumping a little bit tower assembly, as you can see. Yes. And what I need to do now is I will place this over the measuring bowl. Yes. We will level this. We will clamp this. Okay. Now I'm going to close the air chamber. Yes, and now we will pump our press air meter to initial pressure line. Yep. Yeah. Okay, what I need to do now is we need to close both pitcocks, and we need to, whenever we're releasing this, we need to give a little bit time to cool. Then afterwards we are taking our reading. It's 5.3. As per section 6.4.3, the aggregate correction factor GA is equal to the reading on air content scale minus the volume of water removed from the measuring bowl expressed as a percentage of the volume of the measuring bowl. That was 350 milliliter, and reversely by calculating we have got 350 milli divided by 1000 is equal to, now we will calculate this, 350 divided by 1000 is equal to 0.35 liters. 0.35 liters. Here we go. This is divided by 1000, which is, this is divided by, now this is equal to 0.00035 cubic liter. At last, we need to divide this 0.07. Yeah, this is equal to 0.05. Yeah, this is, we need to multiply this with 100. So if we multiply this with 100, it's gonna be 5%. So this is equal to 5%. And what we need to do, so the aggregate correction factor is GA is equal to 5.3, and 5.3 which we receive from air content occurs in 5 aggregate. So here we got 5.3 minus 5. We got here the percentage is equal to 5.3 minus 5 is equal to 0.3%. 0.3 percentage. This is our correction factor for course and 5 aggregate based on our calculation. As you know, during test procedure, I pass through, or I ignore, I escape our some information regarding determination of aggregate correction factors. As per section 6.1, we have gap procedure. We need to determine the aggregate correction factor on a combined sample of fine and coarse aggregate as required, or as directed in section 6.2 to 6.4. It is determined independently by applying the calibrated pressure to a sample of an dated fine and coarse aggregate in approximately the same moisture condition, amount and proportions occurring in the correct sample under test. So that's what's happening. As per section, according to 6.2 section aggregate sample size, we need to calculate the weights of fine and coarse aggregate present in the sample of fresh concrete, whose air content is to be determined as follows. Yeah, I need to write down F is equal to A divided by B multiplied by FB, and also CA is equal to A divided by B multiply by with CB. By putting value, we get mass of fine aggregate, which FA is 0. This is equal to 0.007 divided by 0.015. Yeah. So we need to carry on, and this is multiply with 8.40. This is equal to, calculate them. I need to calculate them now. F8 is equal to 0.07 divided by 0.015 multiply with 8.40, which is equal to 3.91. 3.9. We will count it to, yeah. Now I'm starting the mass of coarse aggregate 13 mm. CAS is equal to 0.007, which is divided by 0.015, which is batch weight, and this is multiplied with 11.61, which is weight. And let me explain a little bit 0.007, which is measuring bowl volume. And at the same time, I will write it down as well, MBV, measuring bowl volume. And 0.015 is batch weight. Yeah. And this is multiplied with 11.61 is 13 mm aggregate used in our trial. So this is gonna multiply with I will calculate this initially. This is gonna equal to 0.07 divided by 0.015 multiply with 11.61, which is equal to 5.417. This is equal to 5.417, or rounded as 5.42 kgs. So, or we can say 5.42 kg. Next. Okay, mass of coarse aggregate 20 mm. CAS is equal to 0.007 divided by 0.015. We need to sort it out and multiply this with 3.77. I'm gonna use calculator and clarify it now. 0.07 divided by 0.15 multiply with 3.77, which is 1.759. Or we can say, if you round it, it's gonna be about 1.76 kgs. As you can see, it's a bit complicated. You know, we have got it in rough data, but I'm gonna clarify this and sort it out, and also in the same time I will indicate it where it comes from. So we have got 8.40. 8.40, we got based on our trial mix design. So we have got natural sand, and we have got 8.40 here, which we got here as well. And also we got this from natural sand. We got 11 point. We have got 11 point here, 11.61. 11.61 is our aggregate, which is 13 mm, based on our mix design, our trial. So we have received that from here, which was a little bit confused sometimes for some people, because we need to clear it. And also we got 3.7. We have got 3.77. This is 20 mm aggregate, which we took this from here, and we did our trial based on this. I hope this is sorted out. And also, as per note 5, the aggregate correction factor will vary with different aggregates. It can be determined only by taste. Since apparently it's not directly related to absorption of the particles, this can be made easily. Ordinarily, the factor will remain reasonably constant for given aggregates, but an occasional check test is recommended. Okay, we have got a report, almost final section. We can say section 10, as per section 10.11, we reporting the air content test result. It shall be reported to nearest 0.1% after subtracting the aggregate correction factor. I appreciate your patience regarding watching my video, and I appreciate it. Thank you very much.